All right. Complete the following statements. The initial number of individuals in Stacy's family are what?
8 generations.
What's the key word there?
Estimated growth.
Exponential function.
Look at part 8. What is... You're shouting out words that aren't even in that.
0.
Initial.
Dang, stupid.
Below isn't even in there. I need y'all to lock in.
It says 0.
I thought we were reading it.
Initial. What does initial mean?
The Y.
The beginning, the y-intercept. So the initial amount of individuals in Stacy's family are 2. Now, first period I had people shouting out 0. Can you have a family without 0 people to start it? No.
The 0 is the other one, and it's sulfate or acetone.
Miss, how was the first time you heard it?
Part B. The number what?
Increase.
Increases. The line is going up from left to right. Write a function that best represents the relationship. Well, our equation is y is equal to a times b to the power of x. What is a?
A is 2.
A is your initial value. What is b?
100%. No.
B stands for the factor.
1 is 1.
How do you know what the factor is? It's what you are
Percentage.
multiplying by. Okay. How do you find the factor? The formula is 1 plus or minus the rate, or the percent, is equal to the factor, the number that goes in the parentheses. Now, there's one number that we already have. That is A. What is A? 2. Okay. Let's find that number that that's B. It says that we increase by what?
100%.
100% each year. Now, what is 100% as a decimal? 1. So 1 plus 1 is 2. So our factor is 2. Look at your y values. What are you multiplying every time?
2.
And could you also be like,
2.
100% each year?
2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64.
100% of 2 is 2, right? Or like you just aren't.
Yeah, you add it. So like 100% of 4 is
But a lot of students, yes, that is true, but a lot of students will see the 100% and want to put 1. You have to think about that formula. 1 plus or 1 minus. Okay. Part D. The number of individuals in Stacy's family at the end of 5 generations will be what?
128.
256.
It says it right there. Oh,
256.
Generations 5. Why are you always so adamant about the wrong answers? Like, you just double down on the wrong answers.
Ooh.
You.
I said the last generation. I didn't know.
You like to argue,
He said 256.
and it's like, I'm about to die on this hill about 128, and no.
I didn't notice it said 5 generations.
That's called you're not reading.
Yeah. I read.
And you still haven't come in to do your corrections. Number 2. Jamal's bank account earning annual compound interest was open. No additional deposits or withdrawals. The balance account after X years can be modeled with what? This equation, right? Complete the following statement. What was the initial balance?
100.
You see it in 2 spots. Where?
On the graph and on the equation.
The equation and on the graph. Very good. The balance increase is at a rate of percent. If it's the percent, we're talking about the what?
The factor.
Percent is the rate. Think before you speak, please.
Isn't it also the factor?
No, the percent and the factor are not the same thing. The factor is the multiplier. It's the number that you are multiplying every single time. What is the factor? You should know the factor.
1.04.
All right. 1.04. Now you have to think about it. We get the 1.04 because we got that from the equation, correct? But what did you add to 1 to get to 1.04? 0.04. Now, 0.04 as a percent is what?
4%.
So, even though you see 1.04 in the equation, we're increasing at what? 4% each year.
Oh, slow.
Okay? The balance in the account at the end of 10 years will approximately be what?
150.
You go to the number 10 and you go back across 150. Jamal's not very good at saving. How many years will it take for Jamal's balance to what?
Double, 17.
Double. Where did we start with?
100. So we have to go to
Started at 100. So if we're doubling that,
18.
we're looking for where it went to what? 200, which was
17.
It's 17.
17.
And then
17
you go
years.
To 200 and then you slide over to the dot. And then you go down.
Over here is saying 18.
Am I off?
No, it's still
Seven-
I am off.
Just before.
I am off.
17 just before.
You're right, Kaylee.
Oh, half a year.
You are right. I was wondering why my key said, okay, yes. If I zoom in, notice the 17's not on there. It's at the 18.
I'm getting technical here.
Oh my
Well,
goodness.
kind of need to be technical. So, yeah, it is
You
18.
can't zoom in on your finger.
Exactly.
It will be more obvious on the STAR test.
Oh, okay.
I swear
All
it
right.
was 17.
But Miss Lovelace made these graphs, so that's my bad. All right, number 3. Calm down. Each year, a local country club sponsors a tennis tournament. Tournament play starts with 128 participants. During each round, half the players are eliminated. What's the initial number of participants? Even though you look at the graph and it looks like it's at the 130, what do you need to do, Spencer? Read. And if you read, what do you notice? The initial number is 128. Very good. The number of participants decrease at a rate of
50.
what is the factor?
I don't know.
We are multiplying by what?
Half.
We are eliminating half of the players, and half of the players is. Boy, how do you. Some of y'all need to go back to math. No.
What?
No.
It's 50. The only way,
Casey's right.
the only way for 60 to be
Wow.
the number is if the initial number was 120.
Wow. How do you get to 50? You subtract
50.
50. So 0.50 as a percent is
50%.
50%. In no world is 60 half.
Exactly. Come on.
60.
What's tripping?
All right. So we have our A. We have our factor, which is B. We can make our equation. Our equation is y is equal to what?
A, which is 128,
Mm-hmm.
parentheses 50, 0.550.
To the power of x. Approximately how many participants were left after the first round?
75. No, 65. 64, my bad.
How about we think before we shout out answers?
64.
Every round we're eliminating what?
50%.
Half. So half of 128 is
64.
no, it's too late. It's too late to try to dig yourself out of that one. After how many rounds will there be 2 participants left?
7. I want to say.
6.
I'm slow.
Yeah, I need to start thinking.
From here until the end of class, you're gonna count to 3 before you shout out. And I'm talking about 3 Mississippi. 1 Mississippi, 2 Mississippi, 3 Mississippi. And in those 3 Mississippis, you need to be thinking before you shout something out. Stop being so impulsive, please. All of this is going on my video, and you are just shouting out wrong answers left and right.
Joanne, shut up. You thought 6
Yeah,
was
it's
half.
So, yes, 6 rounds. Will there be an 8th round?
No.
Why not?
Because they will be done at the 7th round.
What will be
There will
done?
be one.
What are we talking about here?
There will be no participants. There will be one.
Not that there won't be any participants. What?
They'll win their last match because you can't split up.
Because after the
And that was the right answer. Though.
winner is left. Oh, come on.
Yeah. We find out who the winner is in the 7th round. Okay? You too. 3 Mississippis. In 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year. After 1985, the data can be modeled by an exponential function. What's the initial amount of cell phone subscribers?
285.
Now, even though you see that point and it looks like it's right in between 2 and 400, what do? Read. Kennedy. The number of cell phone subscribers increase at a rate of what? Okay, so think about it. If it increases at a rate of 75%, yes, they gave us percentage in the problem. That tells us that that's the rate, okay? We need to figure out how to change that to a factor. So 1 plus or minus the rate is equal to a factor. Are we increasing or decreasing? Increasing, so we add the 75%. And 1 plus 0.75 is? Whoa.
Wait, I was just getting it.
1 plus 0.75 is?
1.75. Those are the right answer.
Oh, Lord. I think I'm about to re-record this again. All right. What is my equation? Y is equal to what?
285.
Parentheses
1.75.
to the power of x. All right. Approximately how many cell phone subscribers were there in 1987? Do you see 1987 on the graph? No, so that means we need to look at our titles. Which one describes your years?
X.
X. And look at the title of the x-axis. It's specifically talking about what?
Years since.
Years since 1985. So the 0 actually represents what?
1985.
The 1 represents?
1986.
And the 2 represents?
1987.
So how many cell phone subscribers in 1987?
Approximately 800.
900.
Mm-hmm.
800.
900? A little less than 900?
We're just going to put the little squiggly. Squiggly means approximate. Okay. I've said it before. Next one. In what year will there be approximately 2,700 cell phone subscribers? 1988, 1989, 1990. So we go to 2,700 dot down 1989. Question so far. Number 5. Medication. William takes 500 milligrams of ibuprofen for his headache every hour. Half of the medication is absorbed into the body and can best be modeled by the exponential function graph below. Okay, what's the initial amount of medication? 500 milligrams. Okay, the amount of medication absorbed into the body, was it increased or decreased? Decreased. The graph is going down. And it's being absorbed by what? Percentage. 50%.
50.
Half of the medication is being absorbed, right? Half means that our factor is
50. Point from.
whoa, no, think about that. Okay, so 50%. Use your formula. 1 plus my 50%
1.5.
is equal to the factor. So 1 plus the 0.5 is?
1.5.
Wait, so
Yeah.
you what? So decrease? But miss the.
Oh, decrease, sorry.
Yeah.
You're right. You were right, Kaylee. I'm sorry. We're decreasing, so you subtract. So 1 minus 0.50 is 0.50. You are right.
You're pretty good.
Sorry. Okay.
Because it's going downward.
The amount of medication is going down because it's being absorbed into the body. Got it? Okay. Write a function that best represents that relationship. Y equals what?
500 times 0.5 power of x.
To the power of x. After how many hours was what?
Half.
So if you know that we started with 500 milligrams, what's half of 500 milligrams?
250.
And after how many hours are we at 250? After 1 hour.
Yeah.
They tried to trick us by saying hours.
Yeah. How much medication will there be left in the body after 9 hours?
0.98.
Almost nothing left. 0.98,
So there's
Right
always
there.
going to be a small amount being absorbed into the body.
apparently.
Cool.
According to exponential functions, yes.
Great.
According to real science, no. All right, number 6. There will be a point where it's all absorbed. So, the last two are multiple choice. Okay, it does say multiple choice on it. The graph below shows the relationship of an insect population over time. According to the graph, which of the following statements appears to be true? So look at A and B. A says the insect population increased by 4 each day. If it's increasing by 4 each day, what is it implying?
That it would go.
Should it be counted by 4?
That it would be counting by 4 is meaning we are what? Adding, subtracting, multiplying, or dividing. Adding. Anytime you see the word each,
So does that mean that
Each
something
means
will
what?
Be like a linear?
Slope.
and slope means it's
Linear.
linear. If you're adding 4 every day or adding 3 every day, you'll end up with a straight line. But we don't end up with a straight line with exponentials because we're not adding. What are we doing?
We're curving.
Why does it curve?
Because it multiplies.
Because it multiplies, not adds. Very good. All right, so the insect population increased more between day 1 to day 2 than any other day. Well, from day 1 to day 2,
It went up by, it multiplied by 3.
we went from what?
Oh,
12.
From 6 all the way to?
18.
So it went up by 12. What about from day 2 to day 3?
day 2 to day 3, it went from
18 all the way to what?
54.
So that increased by?
I can't do that, man. Like 40 something.
Like, you have a calculator.
36.
So would C be true, yes or no? No. Part D says that the insect population increased more between day 2 and 3, which was 36, sorry,
Yeah.
than day 1 and 2, which was 12. Yes. So your answer would be D. Last one. The weekend of the premiere of the Batman movie
Whoa.
brought in $100 million worth of revenue. The exponential function, we have an equation. So keep that one in mind. Here we go. Which statement is true? The film's revenue increased $100 million each weekend.
No.
What's wrong with that one?
It's decreasing.
It's decreasing.
decaying.
But then also, what does each mean?
Linear. What?
Slow. That's implying that it is a linear function, and this is not linear. B. Or jump down to C. The film's revenue decreased, okay. But it says 100 million each weekend. Once again, slope is linear. So we're down to B and D. What's the only difference between the way B and D is written?
The percent.
On B it says the revenue increased by 60, and then on the other one it said it decreased by 40.
Okay, which one do you think it is?
40.
Because if it goes from 100 million to 80,
What'd you say, John?
because if it goes from 100 million
Hmm?
to 600 million,
It's D.
He said D.
It's D.
D.
You said D?
No, he said D, man.
I said D.
So Kennedy said B, okay? Kennedy said B. B is a very popular answer choice, and B is the way that Star Test tries to get you, trick you. Where do you see 60%?
Up there. Oh, what the?
If you look at the equation, they know you're going to look at this number right here inside the parentheses, but that number in the parentheses is my what?
Factor.
And my factor is what? Not the same thing as your rate. The rate is the percent, not the factor. The factor is what we're multiplying by. So how do I go from the factor to the rate?
You have to subtract 1. You have to subtract the factor by 1
What minus
and find it.
4?
Hey, where is it?
Oh, you
So-
have to subtract.
So we're subtracting that, we're decreasing, right? What did we decrease?
0.4.
0.4, and 0.4 as a percent is
40%.
okay. It's very, very easy to look at that number and automatically think 60%. Okay,
Another thing is,
always do the
another
math.
thing I noticed. Another thing I noticed.
What's that?